अच्छा હવે 7.25. A small town with a demand of 800 kilowatt of electric power at 220 volt is situated 15 kilometers away from an electric plant generating power at 440 volt. The resistance of the two-wire line carrying power is 0.5 ohm per kilometer. The town gets power from the line through 4220 volt step down transformer at a substation in the town. A. Estimate the line power loss in the form of it. B. How much power must be plant supply assuming there is negligible power loss due to leakage. C. Characterize the step-up transformer at the plant. Okay. Now see the requirement of power at the town, that is 800 kilowatt. So that is 800 into 10 raised to 3 watt. Clear? Now power line that is with length equal to 15 kilometer and resistance per kilometer that is 0.5. Therefore total resistance, now this one is 2 cable line, so R that is twice the length of cable into sigma, so 2 into 15 into 0.5. So resistance of the cable through which the electricity is transferred, that is 15 ohm. Now the power required at the place, that is 800 into 10 raised to 3 watt. Now see, it is given to you is transferred at 4220 volt step down transformer at substation. So voltage that is 4000. So current obtained at step down transformer which is at the substation of the village, that is 200 ampere. So power loss, that is I square R. So 200 square into 15. So 600 kilowatt, that is the power loss. Now total power, so power loss 600 and required power 800. That much power should be transferred from the generator, or we can say the power station, to that particular village, because 800 that is requirement, 600 loss will take place. So total if supplied is 1400, then that village will get 800 kilowatt. Now potential drop in line, that is IR, I200 R15, that is 3000 volt. Clear? So step up transformer that should be of 440 volt, right? That should be transferred at 7000 volt. 7.26. Do the same exercise as above with the replacement of the earlier transformer by 40,000 to 20 volt step down transformer. Neglect as before leakage losses to this may not be good assumption any longer because of the very high voltage transmission involved. Hence explain why high voltage transmission is preferred. Okay. Now see the same example we have to calculate. In 25, the step down transformer that is of 4220. Now here we have to consider 40,220. So power required, that is 800 into 10 raised to 3. Voltage 40,000. So I, that is how much? So I, that is 20 ampere. Now power loss, that is I square R. So 20 square into 15, that is 6000 volt, that is 6 kilowatt. Now required power, that is 800, loss that is of 6 kilowatt. It implies that total power supplied, that should be 800 plus 6. So total power supplied, that should be power loss plus required power, that is 6 plus 800, so 806 kilowatt. Now potential drop in the line, IR, so 20 into 15, that is 300 volt. Now output voltage of the step up, that should be 40,300. 300 drop will take place. So when it is transferred to the village, at village, step down is getting 40,220, right? So the transferred, that should be 40,300 volt. So step up transformer, that should be such that it increase your voltage from 220 to 40,300. Now see, earlier in this particular case, okay, the power loss, that is now relative power loss, that is 600 by 1400. 1400 generated, transferred, and 600 that is lost. It implies that the relative, that is 600 by 1400, 0.43, means 43% of power loss takes place. But now in this situation, when the transfer is done at 40,000 volt, then see total transferred 806, loss takes place, that is 6 only. So percentage power loss, if we calculate, multiply by 100, so that is 0.74% only. So we can observe this thing here in example 7.25. The transmission that was carried out at 7,000 volt, and now here it is carried out at 40,300 volt. So power loss, that is minimized one. So we can say from this one, the transmission at high voltage, that is advisable. Clear to all of you?